Hello everyone, today we're going to go over the Blind 75 in C++, and today we're working with merge intervals. Now, before we get started, feel free to pause the video to be able to write down the 4 questions we need to do in order to break down the following problem. Again, feel free to pause the video. We first need to ask ourselves for every question what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and then what our output is going to be. So, now to break down the following question that we have, given an array of intervals where intervals I equals start of I, end of I, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So we already know what our input is. We're given an array of intervals. It's start and end. Indices. And we need to merge all the intervals, merge all of the overlapping intervals, and return an array of non-overlapping intervals that cover all the intervals in the input. And so if we were to break down the example 1 and 2, let's say, for instance, we have intervals equal 1, 3, 2, 6, 8, 10, 15, and 18, our expected output that we have is that we need to merge all the overlapping intervals and return an array of non-overlapping intervals. So we have 1, 6, 8, 10, 15, 8, and it looks like from what we have, we're able to merge the rest of the intervals that we have into 15, 8, 8, 10, and then 1 and 6. And it may be confusing to be able to start, but we merge 1 and 3 and 2 and 6 together to make one interval. Since the intervals 1 and 3 and 2 and 6 overlap, we merge them into 1 and 6. Pretty vivid example. Right over here. Just going to put this in the comment section as well. And then we also are able to do the same for intervals 1 and 4, 4 and 5. They come together to become 1 and 5. And it's because 1 and 4 and 4 and 5 are considered overlapping. Alright, it's pretty self-explanatory over what we need to do. And so the technique that I will be introducing you folks to is we're going to be doing a sorting approach with an iterative method, where what we will be doing with the data in order to merge all the overlapping intervals is that we will first sort the intervals based on their start times. Then we will iterate over the sorted intervals, merging the overlapping intervals. And iterating means to go through or scan through. That's just a fancy way of putting it. And so just to be able to go over the steps over how we're going to do this is that for step 1, we need to sort the intervals by their start time. In step 2, we need to initialize a new list for the result. And for step 3, we're going to do a for each loop for each interval in the sorted list of intervals. If the result list is empty, or the current interval does not overlap with the last interval in the result, we're going to append the current interval to the result. And then for part B, if the current interval does overlap, we will merge it with the last interval in the result by updating the end of the last interval in the result to be the max end of the last interval in the result and the current interval. Part B may be a little big, but I'll explain more when we write out our code. And then we have, finally, we need to return the result list. So now the way how it's all gonna look is that for step 1, we're gonna sort everything with our intervals, where we get up here, begin, end, and then we're gonna have a list that we're gonna create, which will be a vector int. Then we have a list inside of a list, which is why we have vector int, and then we have result. Then we're gonna do step 3, which is gonna be our for each loop for auto and interval. For intervals, we're gonna do A and B. If result is empty, or result back 1 is less than interval 0. So that means that we have a maximum that will be less than our minimum interval in this case. We're going to push the current result that we have inside of our list, so that way we can figure out exactly result.push back interval. We will add the following index of intervals that we have not put in inside of our result list. And then else in this part, if it does overlap, we will have result back 1 to be the max result back of the following next interval that we would have, interval 1. And finally, we will return our result. Just make sure that we have everything right. We sort, we create a list, and then we're going to scan throughout our entire intervals array. And what we will do for everything that has not been added, we will add our interval inside of our result list. And for part A, if the result list is empty or the current interval does not overlap with the last interval in the result, we're going to append the interval to the result. That means we're going to put it inside of our result list. And then for B, if the current interval does overlap, we're going to merge it with the last interval in the result. We're going to merge these two together. And then updating the end of the last interval right over here into the result to be the max end of the last interval in the result and the current interval that we would have. So we are just focusing on merging these two together. Then we return a result. Let me just make sure everything's all correct. Let's run this. All right, it passes all the test cases. Let me just clean all this up for you folks. So that way you're able to get a good look and see from the whole result that we will have. I'm going to put this in the comment section as well. Double check. Submit. All right, and it passes all the test cases. So to give a breakdown on the time and space complexity for our solution, the time complexity is going to be O n log n, where n is referring to the number of intervals, and this is because we have to sort the intervals first, which takes O n log n time, and the subsequent merging of overlapping intervals takes linear time, hence the extra n. And then the space complexity is O of n, where n is the number of intervals, and in the worst case scenario, none of the intervals overlap, and the result list will contain all the original intervals. So yes, this was merge intervals in C++. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.